Oh, everybody, it's time to look at bootlegs. We are here in the cave, Adam Savage with John from Lumafield, hardware software genius friend of mine, Zach Radding, and we are going to be looking at some real and fake Apple chargers and some real and impressive fake Apple AirPods. Lumafield has scanned these, and do we know which one of these is real?
We can kind of tell, but it's close.
Yeah.
Yeah, things fit a little differently, maybe not quite as lined up, but it doesn't have that same feel.
It's amazing how close it can be, and yet you can really feel the difference.
Yeah.
That's significant. Okay, sorry.
But the question is, if you're not just flipping the prongs open and closed,
Right.
is there any difference?
Is it functionally, what different functions does the Apple real one have versus the...
Let's look inside.
All right. So
and I'm going to guess this is about like an order of magnitude cheaper. Is that correct?
Yeah, absolutely. Just a few bucks on eBay from a sketchy seller.
Amazing.
So here, let's take a look. This is a CT scan of the real charger. So let's take a look at what's inside here. A lot of components, but Zach
Looks like a
can
VHS
tell
tape
us
up
what's
there
going
on
on.
the
Yeah,
top
definitely
center.
got one of those. Yeah, I mean, this is all for power conditioning and making sure that you've got good, clean power, and it's converting AC to DC and doing it efficiently because we don't want to burn up a lot of energy and heat. So there's a big buck converter, as they call it. So some inductors, both for doing the power conversion as well as filtering. And there's probably some capacitors. There's probably a big bank of capacitors someplace, maybe this right here, that smooths the power out. And let's see. Oh yeah, you've got multiple circuit boards in here. Oh yeah, you've got quite a bit of circuitry to kind of make sure that all of the power gets exactly the voltages that we're after.
So this is all to take in the power that's coming out of the wall and turn it into the exact power the computer needs.
Yeah, the DC voltage rails that it's looking for.
And the more precise it is, the better the better it is for the computer.
Yeah, the happier the computer is, the happier the batteries are, all of that. Having it really nice and smooth just gives you, just better functionality and longer battery life and all of those things. So
There's also, these are MagSafe chargers, so there's a little bit of logic, I believe, that goes into, turning the light on the connector here green when it's plugged in, doing a little bit of a handshake with your computer, that kind of thing.
Yeah, there's definitely some smarts in there. And you can see this is a circuit board, a pretty big circuit board with a lot of components on there. So it's doing a fair bit in just a little charge brick.
So we can scrub down like this and take a look at these components.
Just amazing.
Yeah.
Yeah, a lot going on. There's some processors attached there, microcontrollers, I guess. So.
Yeah, they're probably doing the DC-DC conversion. They're handling it. Oh yeah, and there's the big electrolytic capacitor in this guy, folded over on its side for smoothing. And then there's probably, like I said, a bank of smaller capacitors for the high frequency smoothing.
All right, do you want to see the fake?
Yeah. Looks structurally similar off the first glance.
Has a lot of the same bits and pieces, some of the bigger components. It looks like only 2 inductors. Yeah.
And a lot less circuitry.
Yeah.
A lot less.
But it does have a big electrolytic cap in here. It's got the heat sink around here. I actually didn't see the heat sink, so these are probably MOSFETs over here. I'd be curious to actually look at this heat sink on the real one to see if it's any more robust. Actually, another heat sink here. Oh yeah.
Oh, the heat sink wraps all the way around.
The heat sink wraps all the way around. So that's a pretty significant difference. So
that's a lot more metal in the real one.
And it's actually just spread out over a larger area, so the thing itself won't have hot spots. The whole thing will kind of radiate heat a little more evenly, as opposed to just in a couple spots.
Right, and because you have more metal, you have a lot more room to dissipate that heat.
It's true, and then on top of that, I'm going to guess that their design for their DC-DC converters are more efficient, so they probably have less heat to actually dissipate.
Yeah, this is thinner metal here. Than in the fake. So I think it sounds like you're right. And this is a great example too of where there's an extra assembly step involved in forming a piece of metal or a couple pieces of metal that completely wrap around. rather than just being dropped in as we see in the fake.
Harder to manufacture, but probably worth that little bit.
Am I correct in also assuming that having that wrapped around the PCB is also as a sort of a shield both for radiation coming out and radiation coming in?
Yeah, that also could definitely, that definitely is the case as well. If you look at the real one, you can actually see a lot of inductors. So these are called chokes, these little guys. They're for blocking high frequency noise. So this one and this one and...
Oh, they're little wrapped ferrite cores?
Exactly.
Okay.
So that's actually blocking noise going back onto the power line. This guy, I don't think.
So that's the equivalent of the ring that you often see on some of your cables.
That
goes around the cable to inhibit interference.
It's doing the same thing. This is operating a little differently, but yeah, very similar function. So they probably needed to add all of this to make sure that it passed all of the FCC certifications. These guys probably don't.
Ah, sure. Yeah, now that I'm looking at the two, there's structural similarities, but you can really see that there's like 1/10 of the density of stuff going on in the fake one.
You don't see that same filtering.
Oh, look at that.
There's one filter.
Right. Oh man, what a view. It's still, there's a huge amount of engineering going on.
It's still impressive, absolutely. Oh, they have through-hole capacitors in this. Is that what that is? Or that also could be. No, actually, I take that back. That's not. That is actually a thermal protection. I bet that's a thermal protection device.
I love that you can figure this stuff out. It's an amazing.
Yeah, that's a mauve, I believe.
Wow.
I can tell by the way the pins attach to it at weird angles. But yeah, the power control IC, solder blobs.
They aren't hugely consistent.
No, this might even be assembled by hand. It's hard to say. I mean, this is all through hole. All of these things are through hole, like the wires coming down and going into the pads.
When you say through hole, that's like the standard boards that I used to make when I was a kid. You put thing through, solder.
Yeah, that's how all these components are assembled, as opposed to this is probably all surface mount.
Right, so that's where you put it on top of it and you bake it. And
Exactly. So this has a lot more manual labor. Yeah, that's definitely a MOV, which is a protection device.
Tell me are there actual dangers associated with the increased simplicity of the cheap charger?
I mean, again, it's a lot of, in a short period of time, probably not, as long as it's actually functions and puts out the voltages that you want.
I'm assuming the computer can also adjust the voltage it's getting to certain needs?
To a point.
Yeah.
At some point it can't.
Yeah.
So, you're relying on the whole system to kind of work together.
Right.
So some of the safety features that are missing out of the lesser expensive power brick, may come back to bite you. If, I think heat is probably the biggest thing. Looking at this and kind of how they manage heat, I would worry if this was tucked behind a couch and covered up and,
Which is really easy to happen.
It is, and, over time, if you get frayed wires and it builds up a little more extra resistance, that'll increase the heat, and all of these things kind of, can build up and produce a dangerous situation. Out of the package, is this dangerous inherently? As long as it puts out the right voltages, no, but you just don't know.
But I mean, I can imagine someone handing me this and saying, oh, here's a charger for your computer, and me going, what weird doppelganger universe have I entered in which Apple products feel like this?
Yeah.
It is actually, I mean, I can see that it's an incredibly well-made, I mean, photographically, it would be really hard to tell the difference, but the moment you touch them, it's pretty clear.
It has a different feel. All the fit and finish is
Every
just
last
very,
little...
very different. Actually, even in the weight. Yeah, it's similar. They've got that pretty close. It's not...
Yeah, this is actually probably like 15 grams heavier or something like that.
Maybe that.
Yeah.
This nut here is grounded in the real one and not in the fake one. If you buy like a different version of this that has a grounding pin, for instance, like the UK version of this, then this will ground your power brick.
Wow.
Because actually, in UK, everything
isn't connected. So the fake one.
So with Apple, that would wow.
Now this doesn't come into play in the US because it's a 2-pin connector.
Yeah.
But
yeah. So here's if you see here's the wire connecting to that in the real one.
Yeah. Let's see. Why don't you go to the counterfeit guy? So there's something disconnected So like this, there's a hole, which is normally where a wire would connect, which is the pin on the inside of the plug.
This thing here.
Yeah, exactly.
Okay.
So that's just it. There's something that looks like it should be connected to it, but there's not. Go look at the real one. Yeah, on the real one, there's a wire connected to it.
So it's grounded. That pin is grounded.
Yeah, that's grounded. So what it's probably doing, these connectors in the US, we have 3-pin prongs in our wall, but there's not quite the same requirement as, let's say, in the UK to always have things grounded.
Right.
I'm going to guess in the UK there's a 3-pin version of this, and that pin is what grounds the whole system.
And allows it to pass the CE certification.
All
So-
that,
right,
yeah,
right,
exactly.
right.
So if you took the counterfeit guide to the UK, you would be out of compliance if you tried to ground it.
It's when my laptop has that sort of funny electrical feel to it.
Well, that's a whole different thing. We can talk about that. That's
Okay.
Yeah. But yeah, that's definitely something that the counterfeit guy is missing.
That's amazing. I'm really dying to get to the AirPods.
Let's do it.
Can we move to the AirPods?
Let's do it.
All right. Do we know which one here is the real thing and which one is not?
Okay, this one's the real one, the one that's been in my pocket for a few months.
Okay,
good.
those
There
are
you go.
yours. And then
yep.
this is fake.
So open the box. You've opened enough Apple products to know.
I can already tell that even this, on an Apple product, that's a lot slower. Again, its tolerance is between cardboard, but I can feel it.
Yeah, it's fascinating.
Hold on, is this is the real thing, right?
No,
What is that? Okay, I don't even know what that is.
that's the even cheaper version.
Yeah, you got a good
Amazing.
fake and a bad fake here.
And that's not Apple.
No.
Apple uses some plant-based thermoplastic for that kind of stuff.
But that actually looks decent. Like if you compare this, so these are the two. This is the real.
Yep.
This is the fake.
No, this is very... I could be easily convinced. There's nothing here that quickly shows me. Even the snap feels pretty authentic.
Yeah.
Even down to
Yeah.
the little sound. And
No,
then
it looks. If I grabbed one off of the table, I wouldn't know which is which.
yeah, I can see that the slot is a slightly different shape. There's a difference in the sharpness there. But good. Among everything we've looked at today, this is by far the most robust copy I've seen.
Yeah. No,
That's-
definitely. Let's look inside.
Okay.
Yeah, all right, so let's start with a CT scan of the real ones.
Okay.
So
Look at how dense that
these are
is.
the real AirPod Pro 2nd generation in their charging case.
Yep.
There are a few cool details you can see. You got a bunch of small magnets here around the inductive charging coil, which is here.
Yep.
I'll peel away some of the lighter
Oh, okay.
materials here. So you got the inductive charging coil here, some small magnets around it, a little magnet in the middle. What these are doing, if you remember when Apple released these, one of the things they promoted is you can charge it not only on an inductive charging mat, but also on the little watch charger. If you have this
Right.
this little medallion here, the real ones will snap onto that really nicely. They'll center it
Right.
onto this small charger. So it's got a bunch of little magnets to do that. An intriguing detail is that
Doesn't do it.
It's a counterfeit detector.
yeah, that's right. That's right. One of the
Okay,
intriguing details about this case is that the lanyard eyelet on the side is connected to something internally. It's
What?
connected to it's got this ribbon that goes around. This is the speaker on the bottom of it that makes that little ding.
Yeah.
And then it's connected to this pad that the lightning port is
This is
integrated into.
probably shielding, RF shielding. Any kind of metallic pass through in the plastic, often they will shield it.
Wow.
Yeah.
Or for static or a
So
number
then,
of different
because
things.
this is a
Right,
piece of metal that reaches the outside of the case, it could be a place where interference could enter.
Could enter, or like static charge could get in.
So
like if-
that's
This
gotcha.
is a way to make sure that it goes around the electronics
Right.
instead of through.
That's right. Classic Apple design, they decided they wanted a metal eyelet on it, and then they gave themselves a bunch of engineering challenges, which then they solved. I mean, they could have put a plastic eyelet on the side, and
And
no
to
one
be-
would have minded.
And to be clear, a static electricity spark can be 10 to 20,000 volts, can
Yeah.
actually genuinely harm sensitive electronics
Absolutely.
pretty quickly.
So if we crop into the case here, you see some of the components. There's a pair of batteries here on either side of the PCB
okay. Yep.
that has the controllers, and then a bunch of magnets inside the case as well that are that are giving you experiences like the lid snapping open and shut, and the AirPods themselves dropping in and clicking.
And those are right. And magnets are necessary for every one of those operations.
Yeah. And in looking too at the at an individual AirPod like this one, the detail here is incredible. So
look, everything about the Apple hardware is so insanely dense.
Yeah.
There is not a square millimeter of unused space in these things.
Peel away the plastic and see what you got here. This is the driver. There are a bunch of microphones here that do things like support noise cancellation and talking to Siri and so on.
So this is a MEMS microphone. I think there's another one at the earpiece. I think there's a third one someplace that's floating around.
There's another one right here.
Yep, at the ear. I think there's one even lower. Oh, yeah, at the bottom. Wow. So they can actually see the difference in sound between as it kind of travels through the ear path and process it and do the noise cancellation really well.
Amazing.
So it understands what you're hearing in your ear as well as kind of like what's around you.
So this thing has electronics in it in order to be able to take signals from all four of those microphones and make decisions about what sound it gives you based on that input.
That's right. And now in older AirPods, you would see the battery in the stem. But in the latest versions, the battery has moved into the head, and the stem has some tiny PCBAs that house what I believe are the pressure sensors. You squeeze the stem to signal things. And
probably the antenna. Yeah, you can see the UFL connector coming here. So that's Bluetooth. That's your Bluetooth connection.
Oh, look at that. That's the antenna.
Yeah, that little guy that's the connector.
The battery is now in the head. It's this coin cell battery. If you can even slice through and see the individual lithium-ion layers there with the anodes and cathodes. So.
Yeah, really, it's a much more efficient use of space, having that kind of monolithic battery in there. So that's how they're getting the better battery life. And again, a real dense circuit board. There's a big BGA processor. Actually, these are all BGA. All of these really tiny surface mount chips. And then they also have, this is all rigid flex. So these are flexible circuit boards that come up. And there's also circuitry on these little guys sort of flanking. If you look here, and there's another one over here. Or no, that's the port. But there is some, I'm not sure what that,
down below.
What is that? Is that for touch? That might,
it could be the ear sensor. It knows when it's in your ear.
Ah, right? That's what it is. It's a touch sensor, but for your ear skin.
These guys.
Yeah. Well, one of them I think is, I'm not sure if that's where the actual vent is, but yeah, that's detecting whether it's in your head.
Here, so you can see again. This is the head, and we can slice in a little bit. So here's how it fits with you got the silicone ear tip and so on. And when you slice in, you can see that.
When you look at the complexity of the audio stack, they've got multiple sort of drivers, and there's all this kind of beamforming stuff to make sure that the sound is all combined together really precisely. This is, many man-years worth of engineering to get this to sound as good as it is. That's not an easy thing to design.
And here you got this big coin cell format battery right behind the driver, very efficiently packed in there as well, with individual layers, showing up. The jelly roll, as they call it.
Very cool. Now I'm curious what's in the
so that's the Apple.
All right. So we have two counterfeits here. There's a convincing counterfeit and a really unconvincing counterfeit.
All right,
so,
excellent.
Yeah, we can start with the convincing counterfeit.
That's what I would have drawn to be inside an Apple AirPod.
Yeah, you notice the real AirPod has no wires like this in it.
Yeah, you don't see any wires traveling
completely
around.
Different. You see wires inside very old, the first generation iPods. And that's around the last time you would have seen wires like this soldered onto a PCB in a portable Apple product.
They just, once they figure out how to build it, they figure out how to build it without that.
Yeah, that's right.
Efficiently stacked.
The flex circuit boards and so on kind of replaced them, and they're much more rigid, they're much more resilient.
So this is much more like 1980s style speaker. What you'd find in an old telephone, but it's miniaturized. That looks really familiar. here's your pouch cell. Instead of a cylindrical cell, this is a little tiny pouch cell that's wrapped up for the lithium battery.
All right.
But doesn't nearly take up the space that the
So they're leaving battery money on the table.
a lot.
I don't see the same sensors for telling you that it's in your ear.
It may just not even know.
Are these microphones down here on the stalk there?
This is actually, I believe that is a microphone, but this is an electret condenser microphone as opposed to a MEMS microphone. So again, the sound quality is going to be completely different. And I only count one.
Right.
So they're not doing much as far as noise canceling, I'm going to guess. So that's for picking up if you want to answer a phone call. But
nonetheless, given that this is a fake, there's still a tremendous amount of engineering to get all this into this tiny little form
absolutely, yeah. No, I mean, there is quite a bit in here. It still looks like it's got the little squeeze sensors for detecting that. Let's see, boy, there's
What
some
do you think
interesting.
that pair of things is here? These are the charging pads.
Those are the charging pads.
Yeah.
I don't know. That's a weird shaped thing.
There is a flat pad that they face against.
I mean, that might be what they're
believe.
using for squeeze sensing.
That might be heat sensor or galvanic.
No, it's usually. I mean, in the original ones, you actually did flex the case, and it was
I remember
a
feeling
tactile
it.
switch.
Yeah, you actually
But
feel the clay.
It could be capacitive. But usually a capacitive.
Apple also has the same flat spot.
divot.
Yeah.
Yeah, I don't know what those little conical shaped things are.
It's interesting.
I have to see the actual color of them, and then it's probably obvious.
So this seems to me very straightforwardly exactly what I'd expect in a copy, in that it replicates the functionality just.
That's right. That's right. The impressive thing is this pair of counterfeit AirPods will actually offer to pair with your phone in the same way that real AirPods will.
They have actually spoofed.
They've spoofed some kind of firmware on
For
it.
now.
For now. Yeah, exactly. I'm sure
I
if
think
you
the next Apple update will.
Exactly.
But
Wipe
that's
that away.
impressive. So it went all the way. I mean, because again, with the copies we've seen today, this is by far the one that feels the most like a piece of Apple hardware, and your phone would also be similarly fooled.
That's right. That's right. So let's take a look at the case.
Oh yeah.
A lot less stuff in this
Oh
case.
my God, the
Yeah.
Apple case looked like 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 one of those cars overloaded with stuff from the hardware
That's
store.
right, that's
and this
right.
just looks like
And
half-empty pickup truck.
So the real Apple case has kind of a flexible leaf spring in the lid to make it open and snap open and close and snap closed. This has just a very ordinary kind of wire spring in here. Something you notice here, this does have an inductive charging loop, but it doesn't have that array of
Magnets
that'll snap it into place on
right.
your watch charger.
zoom down to the circuit board. Remember we were talking about BGA chips? These are not BGAs. None of them are. These are much, much older chips. So these have pins coming out the sides.
Like the old IC.
Yeah, I mean, they're not quite through hole, but SOIC and other legged chips, just not as sophisticated, not as modern.
Well, I mean, this is, again, what we'd expect to see, right? Apple's using the absolute latest manufacturing technology to get it small and efficient, and these guys are using 10-year-old, 15-year-old
Absolutely.
technology because it's cheaper and easier to use.
There's also this very primitive speaker here in the bottom of the case that's making the ding sound that you're hearing when you open and close. The authentic Apple AirPods case has some sort of, I don't know what this is. Is this like a solid state speaker, some sort of surface mount speaker?
It might be a balance driver. It's a slightly different way of making a speaker, but it's much more dense and it's hard to tell from that shape.
Let me see
But
if I can. Three very dense components there doing something. Very simple speaker. The presence of wires again, which you don't see anywhere in the real case. And then something else that's interesting here is if we kind of crop in to so we're gonna cut away at the edge here and look at the cross section. You see something kind of interesting, which is that here's the battery. There's just one battery instead of two. It's another pouch cell lithium-ion battery. And then there's this huge, dense block right in the middle. this is just a big block of something that it's either a magnet, it's either a huge magnet that's trying to give it some of the, snap onto charger functionality, or it's just a weight.
Just to give it
that
a little
makes
bit
it
more.
feel more
Wow,
authentic.
right.
Yeah.
I feel like it's a tiny bit heavier, just by grams, but
Not much. They
Yeah.
dialed that in pretty
Yeah.
well.
Yeah.
But they had to because half of it's empty.
That's right. There's
right.
not as
So
much
that
going
could just
on
be
here.
literally a bit of zinc alloy just sitting there.
That's right. So you also have a third pair of AirPods here.
This is this weird one I
super cheap.
opened up. Now, that's this right there. This is how I knew.
What? This doesn't look like an Apple cable.
This has, and I think, yeah, okay.
I mean, it's white.
It's white. It weighs half of the weight. Oh my God, this is excellent. Oh, just that.
It rattles.
And this is the real one.
Yeah.
You can hear that. Everything about this feels cheap.
Yeah. These are toys.
They're spectacular.
But I mean, again, far enough away.
No,
Yeah.
I mean,
It's yeah. Again, if you were just looking for the fashion accessory, like
right.
a white thing in your ear that looks kind of like that, this could be a thing.
can we look inside these?
Yeah.
I
so
can't wait.
here's a look at the case.
Right.
So
Even
these are the
simpler.
really, really cheap AirPod case. Even simpler. This doesn't have an inductive charging loop at all.
Nothing.
So this won't charge on a mat. There's
weight?
There's less metal in here in general. Well, it does have a weight actually.
Oh.
It has another weight. This big bar going through the middle. Now
That is a
this
weight.
can't
just-
be doing anything but being a weight.
They cheaped out on the weight. They
Yeah,
could
that's
have
right.
added
That's right.
more,
Could have
but
added a bigger weight. A lot of the electronics inside the real Apple case are
Yeah.
sort of conformal, right? They're wrapping the electronic, they're filling the space and wrapping electronics around everything. This is just a flat PCB here, and then they got a battery that's on an angle, and
kind of just wedged in.
Yeah, that's right. They put it where there's room for it, and that's it. The rest of this is just empty, and that's why you got this big weight inside. And then we can look too at the
case.
at the single
yeah,
AirPod
oh my
here.
God.
Here again, wires, right? You don't see these anywhere in real Apple products anymore.
These actually, the AirPods themselves don't look all that different from the other counterfeit.
That's
I
right.
think the big difference is the case, but this has some pieces. Wait, that's the magnet for the clip-in, and then there's
the
your microphone.
A single.
This might be the pressure sensor here.
Yeah, that does look like. So yeah, that is. That's your little springiness, and it just flexes on the case like the old ones.
I mean, I keep on redounding to realizing, despite this being a counterfeit, meant to essentially siphon money from a real company,
That's right.
there are real engineers putting this together.
Oh, yeah.
They're not like they're not like, I don't know.
Probably a pretty big team doing
Exactly.
real work,
There's injection molding. There's all sorts of. It's all the same processes. They're just doing it for a completely different end goal.
That's right. That's right. It's a real testament to how far the entire kind of electronics ecosystem has come. That you could create a knockoff that's actually this sophisticated. This is way less sophisticated than a real Apple product, but compared to what any earbud would have done 15 years ago, this is
a giant advancement.
incredibly futuristic. Yeah.
Absolutely.
It's an incredible education to look at the insides of these.
Yeah.
I love how much wire is like wrapped around. That's an interference nightmare, isn't it? Potentially.
I mean, it could be. This is all, but this is just audio, so not too bad.
Okay,
not too bad for interference. But the one thing also, just a fun thing to note, if you spin around, you can see the antenna. So the Bluetooth antenna, they're actually using a chip antenna. That's this little guy right here.
Yeah.
Where and it's on top of the circuit board. It's going to have way less range. It's going to have interference from the circuit board itself. The way that it's on top of the chip. Usually, antennas need to be kind of isolated from everything else. This one isn't. So, my guess is the range is going to be feet, not tens of feet. Oh.
I know.
That rattle, yeah.
Years and years ago, a friend of mine was an antiques dealer and asked me to take a look at two masks and tell him which one I thought was authentic. And I guessed, and I was right. And he was giving me a lesson in, like, you don't need to necessarily have tremendous depth of knowledge that an antiques dealer has to have in order for your layperson to be able to see between these two things. I have an intuition about which one is real. And of all the fakes we've looked at in this videos, like these two are, I really would be hard pressed to tell the difference between them. But this is the greatest difference. It's so hilarious. Like these should go in, like the museum exhibit with this.
That's right.
You can see just how far, how low we can crawl.
All it takes is a little intuition. Not a lot of knowledge. Yeah.
And the fit and finish of this one is obviously crap, right? Like that's not quite.
Doesn't close all the way. Yeah, all of it is. It all rattles.
This has been such an amazing, literal deep dive into these components. I love the view. I love peeling back the curtain on the world, and this is a whole different way to do it.
This is an incredibly fun way to see how intricate everything is, around us. And I learned a lot from you guys. This has been great.
I learned a lot just by looking at this. This has been just amazing. It's fun to see how other people are solving these problems.
I really appreciate you being our navigator for
Happy
the
to.
last 25 years of technological advancement.
We get to see it all right here.
Oh, right. And John, people can crawl through these scans themselves. There's a link in the description that leads to your site, and people can take a look at these for themselves.
Exactly. Fly through interactively and see what we've seen today.
Amazing. All right. Well, thank you guys so much for joining me. Thank you guys for joining us, and we'll see you next time.
Thanks, Adam.
Thanks.